Hello friends, my name is Nitin Pandey, and in this video we would learn about the functional interfaces in Java 8, the Lambda expressions, and then we would run through a practical session of the two. So the functional interfaces in Java 8. An interface that contains exactly one abstract method is known as a functional interface. However, it can have any number of default or static methods, but one and only one abstract method. A functional interface can be annotated by an optional annotation @ functional interface. The syntax is like this. We use the annotation over the interface, and as you could see, we are having only one abstract method. Lambda expressions. The lambda expression is used to provide the implementation of the functional interface. So we would be using lambda expression to implement the functional interface. The biggest benefit of the lambda expression is it reduces the lines of code. Now let's see the demo of functional interface and the lambda, and for that we would go to our Eclipse IDE. So let's open our Eclipse. So yeah, here is my Eclipse, and in this I have already added an interface with one abstract method. So let's use the annotation over here @ functional interface, and this annotation is optional, but we should use it so that our compiler knows this is a functional interface, and if by mistake we add some more abstract method, it gives us an error. Now to instantiate it. So I have already created a main class having a main method. So let's first use it without using the lambda expression. How we would instantiate it without using a lambda expression. So for that we need the reference of the interface, right? But there is no class which is implementing it. So if you're not using lambda expression, so till Java 7, how we would use it is we need a class which implements it. So let's create a class tester_impl which implements the tester interface. Right? Now when we have implemented it, we need to override the doTest method. So let's override it, and for the time being, let's add a simple sysout statement, and let's write here testing. Right? So we have added the method, and now we could, to call it, we do test is equal to new tester_impl, and then we could actually call the method. Right? So this is the way how we used to do it until Java 7. So when we run it, we see the instantiation is done. But this class is not doing anything actually. The only job is to provide the implementation of the method. And let's go to the background and see how our compiler works on these classes. So we see that 3 .class files have been generated. So one for the main class, one for the interface, and one for the impl class. So this is actually not required, because what it is doing, it's just generating providing the implementation of one method. So could we do something for it? So let's comment out this class and try something else. Now we have done this thing. So can we do something like this? Can we implement the interface itself here? Can we instantiate it? Yeah, when we do, we have to provide the implementation here itself. Let's copy this thing and provide the implementation here. Now this implementation, so actually this part is a inner class actually. And since it is not having a name, so this complete is known as an anonymous inner class. But we have given the implementation over here. So let's run it once again. However, our implementation works. So let's go again on the background and see what happens. We see again there are 3 .class files. We see a class file known as lambda main $1, which is actually the class file generated on behalf of the anonymous inner class. So still our compiler is generating 3 class files. Now the Lambda expression comes to the rescue. So now let's see how we would do it using the Lambda expression. So let's comment this code also. And now using Lambda expression, so we do test is equal to, then we use the small brackets and then the lambda sign, and we close the expression. And now I have already copied the statement, so I will provide the implementation over here. So I have provided the implementation. Now let's run it. See, so in only one line of code, which is equal to this code and this code, we have achieved the implementation of the functional interface. Now the question arises, is it only the syntactical difference? So let's go to the background and see. See, now we have generated only 2 class files. So it is also reducing the overhead of the compiler and also reducing the lines of code. Now let's see some more syntax over it. Suppose this interface is having a parameter inside it. So let's say add a parameter int I. Now we need that parameter here itself. So let's call it with this one, and now we need the parameter over here. So we should use like this and print. Now since we know it's a functional interface and it can have only one abstract method, so the method cannot be overloaded, so we could actually skip this data type. So it also gives us the liberty of skipping the data type. We could use like this one, and when we run, we get testing 5. Now let's add one more parameter inside it, and let's this time be of string type. So I've added string s. Let's again go over here, add a parameter and s, and let's pass it, say done. Now run it and we find testing 5 done. So this is how we are using Lambda expression to implement the functional interface. And you can see just only in few lines how we are achieving our task. Now let's see one more practical example. So you must have used threads, and that by using runnable interface. So this is a program till Java 7 which we use to implement runnable interface and to start a thread. So there is a class which is implementing the runnable interface, and there we are starting the thread. Now if you go to the runnable interface, let's go to the runnable interface, and we find this is a function interface. So wait, so do we actually need this thing? Do we actually need this thing? No, right? Because it's a function interface and we could reduce our lines of code. So let's comment out this and let's think about it, how we could do this thing. So let's try doing it with Lambda. So let's do this thing, and again we use the same expression of Lambda, and we could actually provide the implementation here. Right? So and let's copy this thing. Let's copy this and use it here. Now let's run it. We see our thread still starts, right? So we have reduced this much lines of code using the runnable interface. Because it was a functional interface, so we could use the Lambda expression to start a thread using the runnable interface. Right? So you see, right, how Lambda expression and function is making our life easy in case of a functional interface. Because the functional interface is an interface having only one method, only one abstract method to be precise. So for one abstract method, we need not to write so many lines of code. With Lambda expression, it is making our life easier. Please like the video and subscribe to my channel and drop your questions in the comment box. I hope I could clear a lot of your doubts.